Hello everyone, and welcome back to Band 7101 Business Analytics. This week we're going to talk about descriptive statistics. We'll talk about measures of centrality, measures of dispersion, how to interpret them, and then take a look at how to produce them in Microsoft Excel. This week's learning objectives are as follows. So after this week, you should be able to produce a summary of descriptive statistics of numerical data in Microsoft Excel, produce a histogram of numerical data in Microsoft Excel, and identify, define, and interpret descriptive statistics of a numerical data set. So we now begin our analytical journey in business analytics, beginning with descriptive statistics. We're going to take a look at two different kinds of statistics, descriptive and inferential, and this week we're going to visit the descriptive. Essentially, you have a numerical column or field of data, part of a larger data set. It may have some underlying context, and you may want to investigate this column's relationship with other columns in the data. But at this point, all we're going to do is simply take a column of numerical data, so this has to be continuous data, not categorical data, and take a look at its measures of centrality and dispersion. So statistics begins our journey in the analytical portion of business analytics. Statistics is a collection of mathematical techniques used to characterize and interpret data. It's very likely that you have visited descriptive statistics before and even calculated them using a simple calculator in early education. The aim of descriptive statistics is to simply describe the data as it is. Once we are finished describing the data in terms of where its center is and what its variance looks like, then we will move on to inferential statistics, so we can draw inferences about a general population based on our sample data. Descriptive statistics are really the most basic type of descriptive analytics. So taking some already collected data from the past and starting to look at what it might mean. This is likely a review for most of you, so we want to first take a look at measures of central tendency. So in descriptive statistics, we're going to look at measures of central tendency and measures of dispersion. So what do we mean by measures of central tendency? So where is the center of the data? If we're talking about this data, say we have a data set of people's heights. Where is the middle of that data? Are people on average 5'8", 5'9"? So we have three different measures of central tendency we're going to use. The first is that of the arithmetic mean. So we simply take all of the points of data in that column. Again, they have to be continuous numerical data. And we divide that sum over the total number of observations. This gives us the mean or the average. The average is a good measure of central tendency if the data set is normally distributed. So in other words, there aren't outliers shifting the data one way or the other. You don't have one particular value increasing or decreasing the mean too much. And so you can use the average as the center of the data. We're going to talk about skewness when we get to measures of dispersion. If you look at a histogram, so the distribution of the frequency of observations within certain ranges, and it looks like a nice bell curve, then you're pretty evenly distributed around the mean. You don't have terrible skewness, and so that's going to be a good measure of centrality. If for some reason your data is skewed, you may want to consider using the median as a representation of the center. So the median is just going to be the number in the middle of all the observations. This can be found by lining up all the data and selecting the observation that is in the middle in terms of looking at smallest to largest. If you have an odd number of observations, this will obviously be the observation that is directly in the middle. If you have an even number of observations, you will need to take the mean of the middle two observations to get the median. Finally, we have the mode. So the mode is the most frequent observation. This measure of centrality is most useful for data sets that have a small number of unique values. So this is going to be one that is used sparingly. Typically just going to use the mean or the median to describe the center of a data set, depending upon skewness. After we find the center of the data, or the general center, we can then start looking at how the rest of the data is distributed around that center. So the descriptive statistics used to describe how data sits around the center are referred to as measures of dispersion. And measures of dispersion will tell you how much variation there is in a specific numeric variable. The first thing you want to look at is the range. So what is the largest value? What is the smallest value? That will give you an idea of where things are falling around that center. And then you will also want to consider the variance and the standard deviation. So we take all of the sums of differences between each data point and the mean, square those, and divide by the number of observations minus 1. This gives us the variance. It gives us a general idea of how far all of the data points in a given data set are from the mean. So the larger the variance, the more the data are spread out from the mean, and the more variability one can observe in the data sample. The squaring offsets any negative values that might be in the data set. The standard deviation is a somewhat similar measure. It can be found by taking the square root of the variance. Finally, we have the mean absolute deviation that we can sometimes use. This is a simpler way to calculate the overall deviation from the mean. We measure the absolute values of the differences between each data point and the mean and then sum them. So it provides a measure of spread without being specific about the data point being lower or higher than the mean. A box and whisker plot is a way that we can see how data are distributed within a set of observations. So box and whisker plot is divided up into 4 quartiles. Each of the quartiles is contained between the 2 whiskers, and then the middle 50% are contained within the whiskers that bound the box. Within the box, you have an X to designate the mean, so the average of the data set. The line within the box gives us the median, so you can see if the median and the mean are in the same location, then we don't have any skew. If the mean and the median are offset, we do have a skewed data set. If there are observations that lie outside of the final whisker bounds, those can be considered outliers. So these are either going to be 1.5 times larger or smaller than the upper or lower quartile. So with each of these 4 sections being referred to as a quartile. This and the histogram are great ways to visually see how a data set is distributed. A histogram is a chart that shows us the frequency of observations within certain bounds, and we're going to take a look at an example in Microsoft Excel. Skewness is a measure of asymmetry of the dataset, so if that center is further to the left or to the right rather than being in the center, you can see that in the distribution of frequency chart, then you have skew. If you have a nice bell curve just in the center, you do not have skew. Finally, you have kurtosis. If you have one mean in your distribution, kurtosis is going to show you the degree to which the distribution is more or less peaked than a normal distribution. If you have a positive kurtosis value, you will have a peaked or tall distribution. If you have a negative kurtosis value, you will have a relatively flat or short distribution. So here we have a summary of the different kinds of histograms you might see. We have 2 different sets of data indicated here. So we have the red set and the blue set. The top diagram shows you the difference between a peaked and a flat distribution. So with respect to kurtosis, the red here is going to have high kurtosis. So given that this is a chart of frequency, you can see that the vast majority of the observations fall near the mean if you have this high peak here, and they're more evenly distributed the flatter that curve is. On the bottom, we have a comparison of right and left skewed distributions. So the skew falls on the side of the tail. So for the red data set, you can see that it is skewed to the right. For the blue data set, you can see it is skewed to the left. This gives us an indication that actually more observations fell to the left of the mean in this case and fell to the right of the mean in this case. And that can have implications based on what kind of data you're looking at. Let's go ahead now and take a look at an example in Microsoft Excel of calculating the descriptive statistics, interpreting them, and then creating a histogram. So I'm going to pull some data from the UCI data repository. There's a link here on Blackboard. So what I need is numerical data. And just be careful, remember that categorical data can look numerical. You can have a 1 representing a particular category and a 0 representing another category. That does not make the data numerical. It is still categorical data. So I'm going to go ahead and choose numerical here. And let's go ahead and look at this absenteeism at work data set. So I'm going to go ahead and download it by going to the data folder. Okay, so I went ahead and opened up the data set in the desktop version of Excel. So make sure that you are using the desktop version of Excel and not the version in the browser for this. I can see that my data is delimited with a semicolon, so I want to get that out into columns before I do anything else. Actually, the very first thing I want to do is save a copy of this data so that I can preserve the original data set and do my analysis in a new file. So I'm going to go to File and Save As, and save this as Descriptive statistics, absenteeism at work. I'm actually going to go ahead and save a copy as just a plain old Excel workbook as well. To separate these into specific columns, I'm going to highlight the first column and go to data, then text to columns, and it is delimited, so the semicolon is the delimiter, not the space. If I use a space, the issue is all of these words are going to get spaced out into their own columns in the first row, and I don't want that. So I'm going to go to next, and then I do have the semicolon checked. Make sure you have the semicolon checked so that it will separate like that. I can uncheck tab. So make sure semicolon is your delimiter and hit finish. Now I have my data in separate columns and I can choose which piece of numerical data I want to use for analysis. So note that some of these, even though they look numerical, are categorical. If I take a look at the data description on the UCI website, I can see, for example, I have things like social drinker, social smoker, yes equals 1, no equals 0. So that tells me that that's a categorical piece of data. I don't want to use that. I'm going to go ahead and select height for our example here. So I'm just going to delete everything else to make this very simple for us. So I'm just going to highlight those columns and get rid of them. Now it looks like height is in centimeters. This was a study done outside of the US, and those values look like centimeter values to me. So let's go ahead and add that unit in our description. Next thing you're going to want to do is make sure that on the data tab you have the data analysis tools. So there are many different ways to get descriptive statistics. This demo is just going to show you how to do it in Microsoft Excel. So take a look on the data tab and see if you have data analysis. If you don't, you can get it in the following way. So go to File and then go to Options. From here, you're going to go to Add-ins, and then at the bottom, Manage Excel Add-ins, click Go, and then make sure you have the Analysis Tool Pack checked here. Once you have it checked, hit OK. You may need to save and restart Excel, and when you do so, go ahead and check on that Data tab to make sure you have data analysis. If you're having any issues with that, just let me know. From here, we're going to get the descriptive statistics, so including the measures of centrality and dispersion. So I'm going to click Data Analysis and select Descriptive Statistics and hit OK. It's asking me for the input range, so I'm going to click on the arrow to select and then click cell A1. Make sure I get this out of here so that it works properly. Select cell A1. I'm going to do a Control Shift down in order to select the rest and click the arrow again. I do want to make sure I have labels in the first row checked if I do it that way. Make sure you have summary statistics checked and then hit OK. It's going to go to a new worksheet. Okay, so you can see it produced a new worksheet. I'm going to go ahead and right click that and rename that as descriptive stats and then kind of make it a little prettier. I might even just increase the font size up to 14 here. And then the other thing I'm going to do just for readability is highlight everything with a decimal and get that down to 2 decimal places. This is just kind of my own personal preference. You can do 2 or 3 is usually okay. Okay, so height in centimeters, the mean, so the arithmetic mean is 172.11. We can see our standard error here, our median, and our mode. So it looks like the middle of the data is 170 centimeters and the most common height is 170 centimeters. We can see our standard deviation and our variance as well. We have a positive kurtosis, so that's going to be the height of that frequency diagram, and we have a positive skew as well. So we'll see that in the histogram when we get there. We see that our shortest person is 163 centimeters tall, and our tallest person is 196 centimeters tall. And we do have 740 observations. From here, I'm going to create a histogram so that we can take a look at it in addition to these descriptive statistics. So I'm going to go back to the original data set, Control up to get me to the top. Now in the most recent version of the desktop version of Excel, we do have the ability to just automatically generate a histogram. In order to do that, I'm going to use the built-in visualization chart tool that we have. So I'm going to select all of the data in the first column. I clicked cell A1, held Control Shift and hit the down key to get there. Go to Insert, and then under Charts, this is the histogram. So I'm going to select that and just the histogram without any fancy lines on it. So before we talk about what's in the chart, let's go ahead and clean it up a little bit. I already made some adjustments, so it's likely that your data looks a little bit different than mine. The first thing I'm going to do is reformat this bottom axis. So I'm going to right click it and go to Format Axis. What I want is to adjust how the number appears. So this is height. I just want it to look a little bit cleaner, so I'm going to get rid of the decimals. So click the number drop down after selecting this bar option. And then for category, I'm going to choose number and just get rid of the decimal places. So make that 0. If I drag the chart out a little bit, I can start to see those bins. So when you're looking at a histogram, this is what you want to understand, that the bar is indicating the number of observations that fall within a particular bin. So they've chosen the bins to be within 2 centimeters. I could adjust that if I wanted to. So 170 and 172 centimeters, that is where most of the observations fall. That checks out with what we saw for the mean and the median. The next thing I'm going to do is give ourselves a chart title. So I'm going to call this histogram height frequency, and I'm going to put the unit right in the title. If I wanted to, I could add an axis label over here indicating that it was centimeters. Just going to keep adjusting here so that I get it to look a little bit cleaner. The other thing I'm going to do is I'm going to put the data label right on the bar so that we can see the number of observations that actually fell within that bound. So I'm going to right click the bar and choose Add Data Label. So I can now see that 404 of the observations fall within 170 and 172. So more specifically, if you see the parenthesis, that indicates that that is not inclusive. So this includes everything strictly greater than 170 centimeters and including 172 centimeters. That is how to interpret that range. I don't really need the data labels that are 0, so I'm going to go ahead and just select those individually and delete them. Data visualization is both art and science, and once you get into that course, you'll start to see what I'm talking about. If I wanted to, I could also adjust the number of bins or the bin width. So for example, if I wanted to make the bin width, say 5 centimeters, I could do that. And you would see the distribution would kind of be similar, but you would see it change quite a bit. I'm going to go ahead and stick with what it recommended because it does want to tease out these 143 observations here. So now that we have our histogram, let's go ahead and see if we can interpret it. We do have this skew to the right, so indicating that more of the observations fall to the left of the mean. So indicating that more of the observations fall on the shorter end than they do on the taller end. We also have 29 people who are quite taller than the rest. Because this is height, it includes both men and women, and we know on average that men are taller than women are. We could maybe do some interpretation there. Let's go ahead and create one other visualization here. So I'm going to highlight the data again, and this time I'm going to insert a box and whisker plot. So I'm going to click the histogram options again and choose box and whisker. This one's going to take a little more finesse to get to look right. I'm going to go ahead and cut it and bring it back up to the top of the data. So what I need to do here is adjust this axis. So I'm going to right click and say Format Axis. Let's bring the minimum up to, I have the descriptive statistics. The minimum is 163 and the max is 196. So let's go ahead and bring the min up to 162 and the max to 197. This data label doesn't mean anything whatsoever, so I can simply just delete that portion of the chart. I'm also going to make sure I add a chart title, so box and whisker height in centimeters. This also makes sure that we understand what unit of measure we're using here. We can see that we have several outliers here that are on the outside of the lower and upper quartiles. We can also see that the mean is higher than the median. So that checks out with the right skew that we saw on the histogram. Based on the data that we were looking at, can make some interpretation, say that most people do fall within a specific height range. If I knew what kind of occupation this was, I could also maybe make some assumptions based on that. It would all depend on what the underlying data was. So this has been a brief introduction to descriptive statistics, measures of centrality, measures of dispersion, and how to get them in Microsoft Excel, talk about them a little bit, and then take a look at a histogram and box and whisker plot in Excel. If you have any questions about this, please let me know.